hope you're having a wonderful day. This is Mulchaney back again to go over Unit 8. So in the front of your notebook under those units of study, make sure you add in Unit 8 for ratio tables, and it's going to cover 6.12 AB is for our SOLs. Once you have that written in, flip into your notebook, find two blank pages side by side. Please write in Unit 8 ratio tables, and then just remember to fold down that corner so that you can find it very easily. So before we can start talking about ratio tables, we actually need to do some ratios review from what we did at the beginning of the year. So ratios compare two different quantities. And looking at the example that we have there, we have stars, circles, squares, and triangles, and it's asking for the ratios of stars to circles. So stars have to come first, and circles have to come second because stars is first in the problem. So if I count up the stars, there's 1, 2, 3, 4 stars, 2, 1, 2 circles. So it'd be a 4 to 2 ratio. You also could write it as a fraction 4/2 or with the colon 4:2. And all three ways of writing that fraction would be correct. Now remember when we actually did our ratios unit, we would have said, okay, well, maybe you can put this in simplest form. So I can divide it by 2, numerator and denominator, and I get a final answer of 2/1 for my ratio. And that's exactly what we're going to expand on today with ratio tables. So ratio tables are going to build off of what are called equivalent ratios. So equivalent ratios are similar to equivalent fractions and simplified fractions, but because they are a ratio, we're actually comparing two items rather than just looking at the numbers of part to whole. So the example that we have here for the first one is 1/2. Well, I can change 1/2 into an equivalent fraction by multiplying the numerator and denominator by 2, which would give you 2/4. So 2/4 would be equivalent to 1/2. Now, a way that you could show that, I could draw a circle and cut it into half and then shade half. So there I'm showing half. And then I can cut it again. And now you see I have 2 of my fourths that are listed there. So 1/2, if I multiply times 2, is equivalent to 2/4. I can do the same thing for my 1/3. As long as I'm multiplying the same thing for the numerator and denominator, I'm making an equivalent fraction or an equivalent ratio. So say I wanted to multiply this one by 3, numerator and denominator. 1 times 3 would give me 3, and 3 times 3 gives me 9. So 3/9 is an equivalent fraction to 1/3. So let's talk about this in the form of ratios. So to make equivalent ratios, all you're going to do is multiply or divide the numerator and the denominator by the same amount or the same number. If you don't use the same number, you're going to get it wrong. So you need to make sure you're using the same number. So our example, we have 2 dogs to 3 cats. Now dogs is first, so dogs is going to go on top and cats can go on the bottom. And if you want to, you could label it dogs to cats. And I want to try to find an equivalent ratio. I can pick any number I want to. They're not telling me where I need to get. I'm just going to pick it and multiply by 3. How about that? So if I multiply 2 times 3, I get 6, and 3 times 3 would be 9. So an equivalent ratio for 2 dogs to 3 cats would be 6 dogs to 9 cats. You could also think about it, if I do this 3 times, I would do 2/3 plus 2/3 plus 2/3. Again, if I add them, 2 plus 2 plus 2 plus 2 gives me 6, and 3 plus 3 plus 3 gives me 9. So it's the same thing. So you're either doing repeated addition or you're doing this multiplication, but I'm going to recommend the multiplication part. All right, so how does this look in a ratio table? So what is a ratio table? Well, it helps us to organize and solve for equivalent ratios. So pretty much all it is you're just expanding your fraction so that you can kind of lay some numbers out together. So you can see the two examples that I've drawn here for you. You have pens to pencils. So the ratio of pens to pencils is 1 to 3. And this is going to be the ratio that we were given in the problem. So we were given the ratio of pens to pencils is 1 to 3. Now they're asking us to fill in these empty spots in the table. So if I go to fill those in, I need to use my given ratio to move forward into my equivalent ratios. So I'm going to change my color just so you can kind of see what I'm up to. So how could I get from 1 to 2 using multiplication or division? Well, I could do 1 times 2 is 2. Well, if you think of it like a fraction, whenever I do the bottom or top, I also have to do the bottom. So I would do times 2 at the bottom, and 3 times 2 would give me 6. So an equivalent ratio for 1/3 would be 2/6. And then if I do that a second time to get out to this 9, how could I get from 3 to 9? Well, I could multiply times 3. And whenever I do the bottom, I also have to do to the top. So I could use my given ratio, my numerator of 1, multiply it times 3. And 1 times 3 would give me 3. So another equivalent ratio would be 3/9. So all I was doing was taking my given ratio and multiplying it to move it forward into the ratio table. So why don't you try to do the next one? How could I move from this given ratio, 4/6, into this missing space with the 12 and the missing space with the 24? So if I move forward knowing the numbers that I have, I need to get from 6 to 12. Well, to get from 6 to 12, I'd have to multiply times 2. And whenever I do the bottom, I'd have to do to the top. So this would be times 2. So 4 times 2 would be 8. And then to do the next one, I need to get from 4 to 24. Well, I know to get from 4 to 24, I'd have to multiply times 8. And whenever I do the top, I'm going to have to do the bottom. So times 8 here. And then 6 times 8 gives me 48. So you can see how you're filling in those tables. And they're just, like I said, used to organize your equivalent ratios. Now, equivalent ratios can be very, very important as you are doing things in real life. So like our example that we have here, we're talking about paint. So if you go to Home Depot or Lowe's or any of those other places to get paint, they don't just have all the colors sitting on the shelf waiting for you to pick them up. They are just base colors that are on the shelf, and then you have to take them to the counter and they have to mix different colors in different ratios in order to make the color of paint that you want to put on your wall. So this is a real life application of how you can make the color green if you want a specific color of green paint. So it says you mix 3 pints of yellow paint for every 4 pints of blue paint to make green paint. If you use 12 pints of blue paint, how much yellow paint will you need? So let's read that again because there were a lot of words there. You mix 3 pints of yellow for every 4 pints of blue. So to me, that's saying that there is a ratio there. So I'm going to highlight that. So 3 pints of yellow, 4 pints of blue make green paint. And then it says if I use 12 pints of blue, how much yellow will I need? So I know I'm using 12 pints of blue, and it's asking for how much yellow. All right, so that's going to be like a mystery ratio that's there. So let me set up a ratio table using the information that I'm given. So if I look at that first ratio, I'm comparing yellow paint to blue paint. I'm going to make a ratio table. And it's telling me I have 3 pints of yellow for every 4 pints of blue. And I know that I need to get to these 12 pints of blue. And then it's asking me for how much yellow. So I'm looking for this number here for yellow. So I'm going to fill in my ratio table just by using multiplication. So how would I get from 4 to 12? Well, I'd have to multiply times 3. And whatever I do at the bottom, I also have to do to the top. So times 3, and 3 times 3 would give me 9. So I know in order to solve this problem, in order to make the green that I need, I'm going to need 9 pints of, and you can see it's in the yellow row, so I'm going to need 9 pints of yellow paint. And that will make the color green that I'm looking for. So the last problem that I have, I want you to read it. I want you to set up the ratio table, and I want you to see if you can solve that problem for me. So it says if you need 4 cups of sugar to make 2 batches of cookies, how many cups will be needed for 12 batches? So let's highlight what we have important in this problem. It says you need 4 cups of sugar to make 2 batches of cookies. So 4 cups to 2 batches. That's a ratio. How many cups will be needed to make 12 batches? So that's another ratio, but I'm missing this information right here, the how many cups. So when you go to set up your ratio table, you're comparing cups to batches. So I know I need 4 cups to make 2 batches. They told me that in the first sentence. It's asking for how many cups, so this is your question, will make 12 batches. So what you could have done is you could have said, okay, well, I need to get from 2 to 12. I can multiply times 6. And whenever I multiply on the bottom, I have to do to the top. So 4 times 6 gives me 24. So there's my answer. I need 24 cups of sugar to make all my cookies. If you have any questions about ratio tables, please make sure that you ask your teacher, but we will continue to go over this in class next time we see you. Have an awesome day.